Okay, diagram shows two experiments to investigate one factor that affect the rate of reaction between zinc and hydrochloric acid, ZnHCl. So you got two different experiments. I mean, same setup. It's just that the volume here they use a bit different. Okay, and the concentration different. Okay, so one have higher concentration. Okay, the other one is half of it. Okay, so lower concentration. The one that have higher concentration of acid means we get higher rate of reaction. Okay, so but the amount of hydrogen gas produced will be the same because if you calculate properly, okay, if you calculate properly, the number of mole will be the same. Okay, because let's say you calculate the number. Okay, I write the equation first. Write the equation first. The equation is Zn plus HCl. You will get ZnCl2 plus H2. You got hydrogen gas coming up. Okay, and I multiply 2 for HCl. And then if you calculate 50 and 0.5, okay, for mole of HCl, if you use MV over 1000, okay, for this part, you will get 0.025. Itu mistake lah. Okay, try to calculate it. See if you get 0.025, just prove the point. 50 multiplied 0.5 divided 1000. Yes. Okay. So decide if the ratio for acid to hydrogen gas is 2 to 1. So 2 to 1, if you got 0.0 equals 0.025 divided by 2, you get 0.0125. Okay, then you use the 0.0125 multiply 24, which you will get, multiply, you get 0.3 dm cube, or which means 300 cm cube. Okay, so just prove the point. For this also same. If you use this 25 times 1.0, you also get 0.025 more. So that's why then you get the ratio same, then you get the volume same. That's why here, both produced 300 cm cube of hydrogen gas. So it means if they ask you to draw the graph, okay, if they ask you to draw the graph, okay, you must draw the ending must be the same height. Let's they ask you to draw, the ending must be the same height. Okay, it's just that one uses shorter time, the other one uses longer time to complete the lesson. So it's a difference. Okay, just to make sure you can draw the graph in like question B2. Okay, so how to determine the rate of reaction in this experiment? So you can see they are collecting hydrogen gas. Okay, but of course you have to use time. Okay, how much time taken to collect the hydrogen gas? Volume of hydrogen gas released divided by time. Okay, the maximum volume of hydrogen gas released in experiment 1 is VCm cube. So what is the volume of hydrogen gas released in experiment 2 compared to experiment 1? Explain. So in this case, volume of hydrogen gas released. So actually, just now I already calculated, I proved already. If experiment 1 is VCm cube, experiment 2 also should be VCm cube. Same thing. Okay, based on the calculation we did just now. Because number of mole of hydrochloric acid both are the same. That will cause the volume of H2 also same. Just this part, I just doing the same thing. Find number of mole of acid, do mole ratio, and then get the volume of H2 by multiplying the number of mole and molar volume. Okay, because number of mole both same. Unless number of mole different, then the height will be different. Maybe this one is, if let's say this one I didn't change the volume, then the problem will be, this one might get 300, this one might get like 600. So that's why the graph will be like this. The ending will be very different. But otherwise, if they ask you to draw, let's say this is experiment one. Remember, you still have to remember, it's not exactly the same. Okay, the ending same. The time taken for the reaction to complete different. Because for experiment one, we'll have a lower rate of reaction. Lower rate of reaction. So it means if you draw the curve of cell for experiment 2, you have to draw a bit earlier. Just like this. You have to draw a bit earlier. Okay. You can just sketch on here. Then you label the label experiment 2. I can just say 2 lah. Based on the diagram above, which experiment has a higher reaction? Of course, just now we already did, which is the second one. Okay, of course, they also explain either in structural question or essay question. But normally structural question contain like 2 to 3 marks if they ask for explanation. Okay, so how the reaction in experiment 1 and 2 different? So first of all, you can say, remember the factor. After comparing reaction, we say the concentration. After saying the concentration, okay, you have to say, okay, because 3 marks only, okay, so the concentration one, for the point, okay, for second and third sentence, you have to say frequency of collision, frequency of effective collision. Because this reaction is between Zn and HCl, isn't it? Okay, but the colliding particles, the real colliding particles is not the HCl minus. It's between zinc atom and hydrogen ion. Then it becomes N2 plus and H2. This is the real colliding particles. If they ask you write ionic equation, this is how you write. This is the ionic equation. This is the chemical equation. Okay, but the frequency of collision you talk about, you have to use the reactant in the ionic equation between H plus ion and zinc atoms. It's just that for second sentence, you use frequency of collision, F4C. The third point, you have to add one more effective, that's why F4EC. Frequency of effective collision. The first sentence, you can choose either one. You can choose concentration of hydrochloric acid is higher. Experiment 2 is higher than experiment 1. Or you can say number of hydrogen ion per unit volume in set 2 is higher. Also can. You choose this sentence, you choose either one. You talk about this or you talk about this. Can. Both accepted. Table 6 shows 3 experiments carried out by a student. Okay, so if you see carefully, first, all are calcium carbonate chips. Okay, the difference is the volume. A and B, okay, A and B same volume, but the concentration different. So it's like 1.0 and 0.5. So it means this one has higher rate of reaction. Higher rate of reaction. Okay, so in this case, B and C, concentration same, size same. So it means the rate of reaction also should be, okay, should be the same. But the problem is, actually, it will be different. Okay, people don't see it, but it will be different because this one is you add more water. If you add more water, actually, it will in terms of decreasing the concentration. That's why C, right? It will take the longest time for it to complete. not only has lower concentration, but also you add more water. You diluted the concentration of acid. Okay, this one will be the lowest rate of reaction. So this one is number one. The fastest is this one. Second. Okay, but the height will be different. Okay, so because the number of mole different. Okay, this one let's say calculate number of mole of okay HCl. Okay, 25 times 1 or 1000, you will get 0.025, 1, 2, 3. Yeah. Okay. And then this one you will get 0.0125. Okay. It means the volume of hydrogen gas, this one is twice. I mean, this one is twice of this. Okay. Because if you multiply, okay, equation HCl plus CaCO3, you get CaCl2, CO2, H2O. So the ratio between acid and acid and carbon dioxide is 2 to 1. So it means this one you divide by 2, you get 0.0125, multiply molar volume, you will get the trader to calculate. Okay, but just that I show you why is it like that. Why the height different? Okay, so you will get 0.3 dm cube. You can say you got 300 cm cube. Same, you divide by 2 for the ratio, you will get 0.00625. Then multiply by 4 molar volume. Then you will get 0.15, or you can say 150 cm cube. For second experiment, I mean for B, for C, 100 multiplied 0.5. 0.05 divided by 2, you will get 0.025. 0.025 multiplied by 24. Then you get 0.6 dm cube, 600 cm cube. So it means C will have the highest height. C with the highest height because most carbon dioxide gets produced. This is the highest. The height. This is number 1. This is number 2. A is number 2. B is number 3. So which one is A is in the middle? Yes. This one should be C. This one should be B. B lowest amount of carbon dioxide gas produced.